welcome to day 1 of your Unit 3 notes for chemistry. We are going over electron configuration and periodic trends this unit. Today we are focusing on orbital notation, so how to write orbital notation, and some of that background information we need in order to write that orbital notation as well as electron configuration. So we're going to go ahead and start by talking about that Bohr versus Schrodinger model that we kind of touched on just a little bit last unit. So if you remember, Schrodinger he came up with the most up-to-date model. It's called the quantum mechanical model. Okay, and then when Schrodinger came up with his model, he agreed with Bohr. So Schrodinger agreed with Bohr about energy levels. So he said, yeah, Bohr, you're right. Electrons are definitely organized in energy levels, with each level having a different amount of energy. But Schrodinger disagreed that electrons don't have an exact path called an orbit. So that's how that planetary model was kind of disproved. The planetary model looked like those electrons had an exact path and orbit to follow that kind of orbited the nucleus. Schrodinger said no, definitely yes to those energy levels, but they don't have exact paths, they don't have a specific path around the nucleus. Schrodinger's model describes a region in space with a high probability of finding an electron. However, this region in space, it's called an orbital. So no to orbits, yes to orbitals. Okay? So it's kind of weird to think about like a high probability, okay? But so an analogy that kind of might help make this kind of make a little more sense. So if the front office were to call me and ask for you down in the front office, you're getting checked out, okay? They're calling me because they know that it is probable that you are supposed to be in my class during this specific period, okay? However, the front office isn't going to know where you are in my room. They're not going to know what desk you're sitting in or if you're kind of moving around the classroom or not, okay? But they really only have like a 95% chance, they're only 95% sure that you're going to be in my classroom right there because you might be absent, you might be in the bathroom, something like that. So my classroom is that orbital. So the probability that you're going to be in my classroom at this specific time, that's talking about an electron belonging to an orbital. So talking about those energy levels. Schrodinger and Bohr said that electrons are arranged in increasing energy levels. So that means that we're going to have like energy level 1, energy level 2, energy level 3, etc. So these energy levels increase in number and energy as they get further from the nucleus. So energy level 2 is going to have more energy and be farther from the nucleus than energy level 1. Now we can get a little more specific because each of these energy levels also has what's called sublevels. So each of these sublevels represent a shape. So we're going to discuss and use 4 of them, and they're called S, P, D, and F. Now, the first energy level only has one sublevel, and that's S. The second energy level is now going to have 2 sublevels. It'll have S and P. The third energy level has 3 sublevels, S, P, and D. And the fourth energy level has 4 sublevels, S, P, D, and F. So as we increase in energy level, we're adding on a new sublevel. Now we can get even more specific because every sublevel contains those orbitals we were talking about. And these orbitals, that's the specific area where an electron can be found. Now, every sublevel has a certain number of orbitals. So the S sublevel has 1 orbital. The P sublevel has 3 orbitals. D sublevel has 5. And the F sublevel has 7. So as we go down our sublevel, we increase our number of orbitals by 2. Now, each of these orbitals can hold up to 2 electrons, and these electrons must be in opposite directions. Okay, so every orbital can only hold up to 2. So it can hold less than 2, so it can have 1 electron, it can have none, but the maximum it can have is 2. And these electrons must be moving in opposite directions. All right, so this here, this is the model. This is Schrödinger's quantum mechanical model, and it shows all of the different orbitals here, okay? Now, each of these sublevels has shapes, and they've got orbitals, okay? So this here is our S sublevel. Our S sublevel has 1 orbital, which is why there's only 1, and it looks like a sphere. It's got the shape of a sphere. The next, we have our P sublevel. Our P sublevel has 3 orbitals, which is why we have 3 of them here. And I realized that on your black and white copy, it didn't print out super great. So I'm going to go through and outline these a little bit. Okay, and each of these is an orbital. Okay, and these, we said that they have an hourglass shape. So all 3 of these are going to be present. So each orbital for P looks like this hourglass, but we're going to have 3 of them all like arranged differently. So they're all going to have a different orientation because they're not going to take up the same space. Next, we have our D sublevel, and our D sublevel has 5 orbitals, so 1, 2, 3, 4, 5. So we're going to have this D orbital 5 different times in 5 different orientations. And so let me outline this a little bit. If we notice, it kind of looks kind of like a 4-leaf clover almost. Okay, so we say that it's got a clover shape. And then last is F. So F has 7 orbitals. So we have 7 different orientations of this orbital, and they're all present. Okay, and we say that F just kind of has a funky shape. There's no specific shape to it. F for funky, it doesn't really have anything specific, because if I were to kind of go and outline this, the most it kind of looks like to me is like a bunch of grapes, like a bundle of grapes, but there's not really any specific shape. So you are going to have to know that an S sublevel has the shape of a sphere, P has the shape of an hourglass, and D has the shape of a clover. But you don't really need to know that F is funky because there's no specific name for it. Okay, now these are kind of complex to draw, right? They're kind of like, that would be really hard to draw all of these and layer them kind of like here. So instead, what we do is we represent each of these orbitals with a box. So instead of having to draw all of those different shapes, we just represent each orbital with a box. We don't need to get more complicated than that. Okay, so each of these boxes, they're labeled with the energy level, and the sublevel. Okay, so for example, we always start with 1s. So we would show 1 box for the 1s because the S sublevel only has 1 orbital, so we're only going to draw 1 box. and we're saying that this is the s orbital on the first energy level. After that, we could go ahead and draw another one and say, okay, this is the s sublevel. This is the orbital for the s sublevel on the second energy level. And we would just label it underneath. Now, inside these boxes, we're going to put arrows, and these arrows represent the electrons. Now, these electrons, these arrows have to point in different directions whenever they're paired together. This is called the spin. So really, that just means whenever they're in a box together, we're going to have one arrow going up and one arrow going down. So this is good. We would not have this. That's a no. They have to be going in opposite directions. All right, so we know that each of these sublevels has a specific number of orbitals, and every energy level has a different number of sublevels. So we're going to go ahead and fill out this chart so that we know how many orbitals are present in each energy level. So in energy level 1, the only sublevel that's available that's there is the s sublevel. And like I said up here, the s sublevel only has one orbital, so we're only going to draw one box. Now, inside this box, so that box is an orbital. Inside this box, the orbital can only hold 2 electrons. It's a max of 2. So the s sublevel can hold up to 2 electrons. And since the s sublevel is the only sublevel present in energy level 1, energy level 1 can hold a max of 2 electrons. Okay. Energy level 2. Energy level 2 has sublevels S and P. So here for S, we're going to draw one box again. We are not drawing 2 boxes. So even though it's 2S, that doesn't mean we draw 2 boxes. This is just saying it's the S sublevel on the second energy level. The S sublevel still only has 1 orbital, so we're only going to draw 1 box. Okay? Now the P sublevel has 3 orbitals, so we're going to draw 3 boxes. So what I like to do, I like to kind of draw a rectangle and then split it into 3. You don't have to do that, okay? But I really do recommend that you make sure that all of the boxes for your P sublevel touch each other. So even if you want to draw one box and then draw another box off of it and then another box off of that one, that's totally fine. You just want to make sure that they're all touching. That way, whenever we grade, it doesn't look like you only put 2 boxes for your 2P and then 2 boxes for your 2S, if your spacing gets a little weird. So I recommend if they're in the same sublevel, all of your orbitals, all of your boxes touch each other. All right, so this is 1 orbital, so it can still only hold 2 electrons. This is 3 orbitals. Each orbital can hold 2, so the 2p sublevel can hold up to 6 electrons. So the entirety of energy level 2 can actually hold up to 8, because we have a 2s and a 2p, so 2 plus 6, we can hold up to 8. Next, we have our third energy level, and our third energy level has sublevels S, P, and D. So S, again, is only going to have 1 box, 1 orbital. P, again, has 3. And then the D sublevel has 5 orbitals, so we're going to draw 5 boxes. Okay, so 1 orbital can hold 2, so the 3s can hold up to 2 electrons. The 3p can hold up to 6. Then here we have 5 orbitals, 2 electrons in each one, so 3d can hold up to 10 electrons. Meaning the third energy level can hold up to a total of 18 electrons, 2 plus 6 plus 10. All right, last is our fourth energy level. Our fourth energy level has S, P, D, and F. So S again has only one orbital, one box. P always has 3 orbitals, so we draw 3 boxes. D always has 5 orbitals, so we draw 5 boxes. And last, F. F has 7 orbitals, so we're going to draw 7 boxes. Okay, so the 4s can hold 2 electrons, the 4p can hold 6, 4d can hold 10, and the 4f, if there's 7 orbitals, 2 electrons in each, 4f can hold 14. And so the total number of electrons in the fourth energy level can be up to 32. Now we stop at the fourth energy level because after that we've used all of the sublevels. So energy level 5 is just going to look the same as energy level 4. So we have more, there are going to be more than 4 energy levels, but after level 4, they all look the same. All right, so one kind of other way to think about this, all right, is let's say you're going to the stadium because you're either going to see like a concert or sports game, whatever. Your ticket tells you where you're supposed to be during this game, right? So first, it's going to tell you like what stadium level you're on. So are you on level 1, level 2, 3, like nosebleed, whatever. That represents the energy level for our electron. Then it's going to tell you your section number. So are you in section 102, 205, 303, whatever it is. That's like the sublevel. Then your ticket's going to tell you what row you're in that section. That's like the orbital. So that's like this here. And then last, you're going to figure out what seat you're in. That's going to be the spin. So that's going to be like, is your electron pointing up or is it pointing down? All right. So this is how, if one of your friends needed to find you, you would send them all of this so that they could come and see you. Now, again, that's assuming you're not getting nachos or using the restroom. That's where they're going to find you during that game. So that's where we're going to find that electron. Okay. So we can use all of this here to help us write out our orbital notation. And our orbital notation is all of this. It's telling us exactly where our electron can be found. However, when writing out our orbital notation, there are 3 rules that you have to follow. So they're called the off-bow principle, Hund's rule, and Pauli exclusion principle. Now, I don't care if you memorize the dudes' names or not. You just have to make sure that you know what each of them says. So I don't care if you forget that this is off-bow, as long as you remember what this is. So, the off-bow principle tells us that each electron occupies the lowest energy level possible before going on to fill higher levels. So that means we're going to like fill our first energy level and then go up to our second, etc. So this here kind of shows you the order. So if you follow the arrows, it shows that we fill 1s and then 2s, then we do 2p and 3s, then 3p, 4s, then 3d, 4p, 5s, etc. Okay? Now, we're going to take this and make it a little easier to read by filling out this periodic table in a moment, okay? But that's just kind of show you the order that they fill. So you would fill lowest energy and then highest energy. All right, Hund's rule. Hund's rule says that orbitals of the same sublevel will each hold 1 electron before they hold 2. So for example, let's draw a p sublevel here. So there's 3 orbitals. And let's say we have 3 electrons. We would give each orbital 1 electron, okay, we would not give our first orbital 2 and then 1 over here. So this is correct, not this. I kind of like to think of it like a dinner party, okay? So I've made a certain amount of food for my friends, and that's all I've got, okay? And so I want to make sure that everyone has the opportunity to come and get food first before someone comes up and gets seconds, right? So I want to make sure that each of our orbitals, each box, has the opportunity to have 1 electron before a box gets to have 2. All right. The last rule that we have to follow is the Pauli exclusion principle. So this says that electrons share the same, so electrons that share the same orbital must have opposite spins, which just means that they're going to point in opposite directions. Okay, so that's going to be like what I did earlier. We would have arrows, 1 arrow going up and 1 arrow going down, not 2 arrows going down or 2 arrows going up. Okay, so now I'm going to fill out this periodic table. I like to use different colors for this, so if you want to pause the video and go and grab 4 different colors, you are welcome to, okay? But you do not have to. So you do not have to use different colors for this by any means. I just like to do so. All right, so we're going to go ahead and fill this out. So this is our periodic table. And along this side here, we have our periods written out on our periodic table, right? So our periodic table, for example, here, says that this is period 1, this is period 2, period 3, etc. These period numbers represent the energy level that your element has. So elements in this first period only have the first energy level. Elements in this period have 2 energy levels, and so on, okay? So we're going to go ahead and fill this in with our energy level and with our sublevels. So our first energy level, if you remember, our first energy level only has 1 sublevel, and it's just S. So this here, both of these would belong to the 1s sublevel. And this makes sense because the S sublevel only has 1 orbital, which means it can only hold 2 electrons. So this here would be 1 electron, and then this here would be another, so we'd have a maximum of 2. Then we're going to come back down over here, and we're going to start, now we're on the second energy level. We always start with our S, so this here would be 2s, and like I said, it can only have 2 electrons, so we can only take up 2 of these elements. So both of these elements here would be in the 2s sublevel. Then we're going to come over here. So I'm going to switch colors, because in our second energy level, we have the S sublevel, but we also have the P sublevel. That's available now. So we're going to call this 2P. And a P sublevel has 3 orbitals, which means it can hold 6 electrons. And if you count across, 1, 2, 3, 4, 5, 6. So all of these are in the 2P sublevel. That's where they're going to stop. So we're going to come back down now here. So if you notice, I'm kind of reading the periodic table like a book. I'm going left to right, then coming back down to the next line, left to right, back down to the next line. So this here would be 3s. Again, can only hold 2. Go across. This guy here would be 3p. Okay, so I've reached the end, so I'm going to come back down here. And now, here, this is still 4s. So all of the guys over here, these are going to be s. So 1, 2, this is 4s. Okay, but now here, we've hit a block that we haven't labeled yet. We are calling this is our D. This is our D block. Okay, Now, if you remember, our D sublevel became available in our third energy level. So this here is not going to be 4D, it's actually going to be 3D. Okay? And so a D sublevel has 5 orbitals, which means it can hold 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the way to here, these are in our 3D. So after that, now we come here, and this is going to be 4P. Okay, so now that we have these labeled, I'm going to go through, instead of constantly switching colors, I'm just going to say, okay, this is 5S, 6S, 7S. This over here is 5P, 6P, 7P. And then here we start here 4D, 5D, 6D. Now, if you remember, there are 4 sublevels that we've talked about, but we only have 3 here. Okay? The other one is F. So F has to go down here. And if you remember, F gets introduced in the 4th energy level. So this here is 4F. So all of these guys would be 4F. F has 7 orbitals, meaning it can hold 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So then this one here would be 5F. Okay. Now, these guys down here aren't just an island, okay? They belong to the periodic table. And if you look at your periodic table that we gave you, it's showing that your lanthanides here come up in our 6th period, and our actinides come up in our 7th period. So really what I'm going to do is I'm going to show that 4F actually comes in between 6S and 5D. So our 4F here would be in between our 6S and our 5D, and then the 5F would be in between our 7S and our 6D. That's where they go. Alright, so we just went through and labeled this because this here is going to be our guide for writing out our orbital notation. So, like I said, we read the periodic table like a book, left to right, left to right, left to right. And this here, if you follow that, it tells you the order that we're going to write our orbital notation. So on the next page, we're going to do some practice and some examples. So the first one we have hydrogen. So we went ahead and gave you that hydrogen is in our 1s sublevel. That's all there is. And if we find hydrogen on our periodic table, he's over here. Okay? So he would be in the 1s sublevel. Now, this 1s sublevel, what we need to do to figure out how many arrows we're going to draw is we just count what location it is in that sublevel. So hydrogen is in the first spot for the 1s, so we're just going to draw 1 arrow to represent 1 electron. And that's it. Next is helium. Helium on our periodic table is over here. So helium is still in the 1s sublevel, but it's in the 1, 2, the 2nd position. So that means we're going to draw 2 arrows. And remember, these arrows have to be going in opposite directions. And you can make sure that you've got the right number of arrows because these arrows represent electrons. So your total number of arrows should equal the total number of electrons of that atom. So helium has an atomic number of 2, which tells us the number of protons, and our number of electrons equals the number of protons, and so helium should have 2 electrons, 2 arrows. Next we have lithium. So lithium is here. So it's in this 2s spot right here. Okay? However, we have to read the periodic table like a book. That means we're always going to start up in this 1s. So we always start in this position right here, and we go until we hit our element. So we start at 1s and we pass through 1s, and then we hit 2s. That means that whenever we do our orbital notation, we have to include the 1s and the 2s. So if you notice over here, we gave you an orbital for 1s and an orbital for 2s because we have to represent both of those. Now, Aufbau said that we fill lower energy to higher energy. So that means that our 1s has to be completely full before we move on to the 2s. So that means that we would fill our 1s, we'd have 1 arrow up and 1 arrow down, before we go and put any in the 2s. Now, lithium was in the first spot for our 2s, which means in the 2s orbital, it's going to have just 1 electron, so 1 arrow. And you can double check that you drew the right amount because we have 3 arrows. Lithium has an atomic number of 3, so that means 3 electrons. All right, carbon is next. So carbon, if you notice, we gave you all the way out to 2p because carbon is right here on our periodic table. So in order to get to carbon, we start with 1s, pass through 1s, pass through 2s, and then we hit 2p. So that means that we have to include 1s, 2s, and all of the 2p orbitals. So even though we might not have electrons in each of these orbitals, in each of these boxes, we still have to draw all of them because they're there. They might not have anything in them, but they are present, so we have to draw them. All right, so carbon is in our 2p block. So that means 1s and 2s have to be full before we put any in 2p. So we can go ahead and fill up our 1s and 2s. And then carbon is in the second location for the 2p, which means we're going to have 2 electrons or 2 arrows in the 2p block. So in our orbitals, we're only going to draw 2 arrows. And remember, Hund's rule says that every box should have the opportunity to have 1 arrow before we double. So we would put 1 arrow here and 1 arrow here. And it's okay that this box doesn't have an electron. It's fine. All right, next is chlorine. So chlorine, we went ahead and gave all of the boxes, but we need to go through and label them. So chlorine, if we look in our periodic table, it's all the way down here. Okay, so on our periodic table that we labeled over here, that's here. So it's in the 3p section. So that means we're going to have 1s, 2s, 2p, 3s, and 3p all present and written down. And we're going to go in that order. So this, we start with 1s always. Then we go to 2s. And then after 2s is 2p. So 2p has 3 orbitals, which means all of these are going to be 2p. You can either individually label these as 2p, or what I'm going to do is I'm going to say 2p, and then say all 3 of these guys are 2p. After 2p comes 3s, and after 3s comes 3p. So again, any p sublevel is going to have all 3 orbitals drawn. So chlorine, we said that chlorine is in the 3p section. So that means everything before 3p has to be full because we fill lower to higher energy. So all of these guys are going to be full. So I'm going to go ahead and fill up my 1s, 2s, my 2p, and my 3s. Because I know that these are full before I get to my 3p. So now I'm going to check my 3p, and my chlorine is in 1, 2, 3, 4, 5. It's in the 5th spot of 3p. So I'm going to have 5 arrows in the 3p section. So I'm going to do 1, 2, 3, 4, 5. And that's it. And I can double check by counting my number of electrons. 2, 4, 6, 8, 10, 12, 14, 16, 17. Chlorine has the atomic number of 17, so we're good. All right, iron. Iron we're doing from scratch. So on your assessments, on your test, you're going to be given this. Okay, and you're going to have to you're going to have to draw these boxes from scratch. So we're going to find iron first. So iron is right here. Okay, and if I go to my labeled periodic table, I'm going to see that it's here in my 3D section. So I'm going to write out everything through 3D, but I'm going to stop at 3D. I won't do 4P because it's not in the 4P. So once I hit iron, it's in my 3D section. That's where I stop. So I start with 1s always. So I'm going to draw my box for 1s. After 1s is 2s, so I draw my box for 2s. So I did 1s and then 2s. After 2s is 2p. So a p sublevel has 3 orbitals, so I draw 3 boxes. Label it 2p. After 2p is 3s. After 3s is 3p. Okay, and then that's the farthest we've gone so far. So after 3p, we're going to hit 4s. Then after 4s, we hit 3d. And 3d is where we're going to stop because that's where iron is. So we're going to draw our 1 box for 4s. And then we've got a d sublevel. A d sublevel has 5 orbitals, so we're going to draw 5 boxes. And label that 3D. All right, so I know that iron is in the 3D. So that means everything before 3D, all of these are full. So I can go ahead and fill them. Now I'm in 3D, and so I'm going to count to get to iron. So this starts my 3D, so 1, 2, 3, 4, 5, 6. So iron is in the 6th spot for 3D, which means we're going to draw 6 arrows. So we're going to do 1, 2, because remember Hund's rule says that every box gets to have 1 before we double. 2, 3, 4, 5, 6. All right, so I want you to pause the video, try bromine on your own, and then come back and check your answer. All right, so this is the answer for bromine. So you should have found bromine and recognized that it was in the 4p section, and specifically in the 5th spot in the 4p section. So we should have drawn out 1s, 2s, 2p, 3s, 3p, 4s, 3d, and then 4p. And 1s through 3d were all going to be full because 4p was the last one. And then bromine was in the 5th spot, so we should have 5 arrows. 1, 2, 3, 4, 5. All right, so next class, we are going to talk about electron configuration, which is really just a shorthand way to write this, and then y'all are going to play Battleship. So I would try and avoid missing next class if you can, because Battleship is really fun. All right, if you have any questions, please come and see any of us. We're happy to answer them. Otherwise, see you later.